Monitoring and logging. AWS monitoring and logging is a set of practices you can use to verify the security and the performance of your AWS resources and data. These practices rely on various tools and services to collect, analyze, and present data insights. You can then use these insights to identify issues, predict performances, and optimize configurations. Let's look at some importance of monitoring and logging. First, we have security, compliance, and audit. AWS provides services that help you protect your data, accounts, and workloads from unauthorized access. AWS Compliance empowers the customers to understand the robust controls in place at the AWS to maintain security and data protection in AWS Cloud. An audit gives you the opportunity to remove the unneeded IAM users, role, groups, and policies, and to make sure that your users and software have only the permission that are required. Next, we have anomaly detection. Monitoring makes it easy to find patterns of potential security breaches in your infrastructure and then alert the admins to take action. Troubleshooting. It helps in determining the operational issues like when the resources are created, deleted, or modified, and who initiated it. It also helps in performance issues like why compute is running slow. Lastly, we have cost tracking. You can observe your cloud service usage and fee. Increased cost can be triggered when scaling kicks in to meet demand. Strong monitoring solutions should track how much activity is on the cloud and its associated cost. AWS provides some tools on AWS platform for monitoring and logging. These are CloudTrail, CloudWatch, and GuardDuty. You can track your AWS deployments in the cloud using CloudTrail. You can know who did what, where, and when. Amazon CloudWatch is secure, scalable, and adaptable monitoring service that you can use straight away. You don't have to set up, manage, or scale your own monitoring system or infrastructures anymore. GuardDuty is a threat detection service that protects your AWS accounts and workloads by monitoring for harmful activities and illegal conduct. It exposes the notifications through Amazon CloudWatch, allowing you to automate a response or notify a person.
Hello everyone, and welcome to this lesson where we will learn about AWS CloudWatch. Let's start with what is Amazon CloudWatch. When using the AWS services, you might be interested in looking at the services usage while tracking the resources and the applications you run on AWS. AWS CloudWatch is the answer for all this. It allows you to monitor your AWS resources and the applications that you run on AWS in real time. You can use CloudWatch to collect and track metrics, which are variables you can measure for your resources and applications. So with the help of CloudWatch, you can collect and track metrics. CloudWatch enables real-time monitoring of AWS resources such as Amazon Elastic Compute Cloud instances, Amazon Elastic Block Store volumes, Elastic Load Balancing, and Amazon Relational Database Service instances. Users can access CloudWatch functions through an application programming interface, command line tools, in one of the AWS software development kits, or the AWS Management Console. Here are the 4 stages of Amazon CloudWatch that a user can perform to completely visualize the cloud resources and applications running within the AWS cloud and perform an action on the monitoring data. The first step is where the data from all the AWS resources that you want to visualize is collected. So this is in the form of metrics and logs, and these resources can be your applications or any services running on the AWS and on-premises servers. Then the next step is to monitor the selected resources that you are interested in. This involves the visualization of applications and the infrastructure with CloudWatch dashboards. You can correlate logs and metrics side by side to troubleshoot and set alerts and alarms with CloudWatch Alarms. This brings us to the act stage, where you automate the responses based on certain thresholds for the resources. This step helps you perform operations based on the data monitored in the first step. You create alarms based on metric value thresholds you specify, or alarms that can watch for anomalous metric behavior based on machine learning algorithms. For example, set up automated actions to notify you if an alarm is triggered and automatically start auto-scaling to help reduce mean time to resolution. You can also deep dive and analyze your metrics, logs, and traces to better understand how to improve application performance. So this is how the overall stages of CloudWatch works in AWS. Let's move on to next to see what are the services that can be monitored using CloudWatch. As discussed previously, here is a bit more detail to the services within each category that the CloudWatch can monitor. So when talking about the compute services, one can monitor the EC2 instances, the auto-scaling group details, elastic load balancers residing, do the health checks for the Route 53, and monitor the Lambda functions as well. Moving on to the storage and the content delivery, you can monitor the EBS volumes, storage gateways, and the CloudFront. The services for database and analytics is much self-explanatory, and you can see that monitoring of DynamoDB tables, elastic cache nodes, the instances running for relational databases, Redshift data warehousing, and elastic MapReduce can be performed. Then we have some other services where with the help of CloudWatch you can monitor the simple notification service topics, look at the simple queue service, monitor the API gateways, and the estimated gateway charges. So this is it for the session on what is CloudWatch. In our upcoming session, we will deep dive into working of the AWS CloudWatch. Hello everyone, and welcome to this lesson where we will learn about AWS CloudWatch concepts. When it comes to Amazon CloudWatch, these are the terminologies and concepts that are central for understanding and use of this service. We will go through all of them and discuss briefly. A namespace is a container for CloudWatch metrics. Metrics in the different namespaces are isolated from each other so that metrics from different applications are not mistakenly aggregated into the same statistics. Here is a console view for CloudWatch, and we can see 7 different namespaces. Each one of them contain their respective metrics. For example, if you look at the relational database namespace, you will find 60 metrics inside this namespace. In the same way, if you look at the EC2 namespace, we have 316 metrics for this namespace. Metrics are the fundamental concepts in CloudWatch. A metric represents a time-ordered set of data points that are published to CloudWatch. Now think of a metric as a variable to monitor, and the data points as representing the values of that variable over time. For example, the CPU usage of a particular EC2 instance is one metric provided by Amazon EC2. The data points themselves can come from any application or business activity from which you collect data. Here is the namespace for the EC2 instance, and you can see that for EC2 we have 2 different dimensions. One of them is the auto-scaling group and the other is per instance metrics. Let's explore the options for the per instance metrics dimension for the EC2 namespace. In here you can see that we have all of these metrics, and you can monitor the CPU utilization, disk read bytes, or any other metric that you are interested in. For each metric, we have either a standard resolution or a high resolution. Metrics produced by AWS services are standard resolution by default. And when you publish a custom metric, you can define it as either standard resolution or high resolution. And when you publish a high resolution metric, CloudWatch stores it with a resolution of 1 second, and you can read and retrieve it with a period of 1 second, 5 seconds, 10 seconds, 30 seconds, or any multiple of 60 seconds. Statistics are metrics data aggregations over specified periods of time. CloudWatch provides statistics based on the metric data points provided by your custom data or provided by other AWS services to CloudWatch. Aggregations are made using the namespace, metric name, dimensions, and the data point unit of measure within the time period you specify. Here you can see a visualization of the statistics for CPU utilization for the selected EC2 instance ID. It shows the overall CPU utilization for this instance through the day. From this particular graph, we can see that the CPU utilization was maximum during this time of the day. You can use an alarm to automatically initiate actions on your behalf. An alarm watches a single metric over a specified time period and performs one or more specified actions based on the value of the metric relative to a threshold over time. The action is a notification sent to an Amazon SNS topic or an auto-scaling policy. You can also add alarms to dashboards. Alarms invoke actions for sustained state changes only. CloudWatch alarms do not invoke actions simply because they are in a particular state. The state must have changed and been maintained for a specified number of periods. Alright, so this is it for the theory session on concepts in Amazon CloudWatch.
CloudTrail. CloudTrail is a service whose main purpose is to record and trace all the AWS API queries. Every interaction with the AWS Cloud Platform is an API call. You can track, monitor, and keep account activity connected to the actions throughout your AWS infrastructure with CloudTrail. CloudTrail records all the activities made through the AWS Management Console, SDKs, command line tools, and requests made by other AWS services. So let's see how CloudTrail works. First, request is initiated by AWS Management Console, SDKs, AWS CLI, or by any other AWS services. When activity occurs in your AWS account, that activity is recorded in a CloudTrail event. You can easily view your recent events in the CloudTrail console by going to Event History. You can store and archive the events in the S3 bucket. CloudTrail Events. When an API request is initiated, AWS CloudTrail captures this request as an event and records this event within the log file, which is then stored onto S3. Each API call represents a new event within the log. CloudTrail also records and associates other identifying metadata with all the other events. For example, the identity of the caller, the timestamp of when the request was initiated, and the source IP address. For a greater management, new log files are typically created every 5 minutes, which are then delivered and stored within the S3 bucket that has been defined by you during your CloudTrail configuration. This allows you easily to go back and review the history of all the API requests made. The log file contains who, where you have saved the user details, the role you are using, and the AWS service you have used. Where has the AWS Management Console, AWS Command Line Interface, SDKs, and APIs. What contains the actions performed on what resources. For example, a file uploaded to S3 bucket. When did the events occur? Basically the timestamp. Let's move on and look at some use cases for CloudTrail. First, we have audit activity. It monitors, stores, and validates activity events for authenticity. It easily generates audit reports required by internal policies and external regulations. Next, we have identify security incidents. It can be used very effectively as a security analysis tool. CloudTrail event provides very specific information about where an API call was originated from, or who or what initiated the request. Next, troubleshoot operational issues. CloudTrail is to help solve and manage day-to-day operational issues and problems. Understanding trails. Let's see what we have already learned about trails. Without a trail, the service is unable to capture API calls. We have also learned that these trails are foundation building blocks that hold all the configuration information. In this lab demonstration, we will be creating a trail and then generating and viewing events through EC2 instances. So let's go on and implement that together. Okay, so let's take a look on how we should set up our trail within the CloudTrail. As you can see, I am currently in the AWS Management Console. You can either search or click on the CloudTrail here, and that will take us to the dashboard of the CloudTrail service. So if we click on the dashboard from here, this is where you can add new trails and you can see all your existing trails that you have already configured. So for this demonstration, let's add a new trail. The first thing you need to do is to add a trail name. So let me label this as Skill Curve Trail. Next, we're asked to create a new S3 bucket. So S3 bucket is the destination where our log files will be stored. So all the events that are captured related to API calls are recorded into logs, and then these logs are delivered to S3 bucket. So here we can either create a new S3 bucket or say no and select an existing bucket that we have. For this demonstration, I'm going to create a new bucket. CloudTrail will apply all the correct bucket policy permissions to allow the CloudTrail to deliver the logs to that bucket. So let's give this bucket a name. I'll just add SC at the beginning and keep the rest names same. Our next option is to encrypt the log files. By default, CloudTrail logs are stored on S3 with the server-side encryption, so it's automatically encrypted. However, if you want to add an additional layer of the encryption, you can say yes and select the use of KMS, which is the key management service. But for this demonstration, we will leave that as no. We will uncheck the log file validation as well, and now scroll down and click on next. We will leave the default settings as is and click on create trail. And that's it. So to create your trail, it is just few options and configuration details that you need. So now I have selected all those and I'm going to click on create. And there you can see skill curve trail. And we have specified that it was all regions, gave it a bucket name. We haven't associated any CloudWatch logs yet. And logging status is still on. So although we have created this new trail, there are additional configuration options we can apply. But we can only do that once the trail is created. Here, we are just simply seeing our log files being generated. Now, we will select our trail. Here, we'll wait for at least 5 minutes for your last log file delivered to be updated. Refresh the page after every 5 minutes and you will be able to see your current date and time. There, we have today's date and time now. In the search bar at the top, enter S3. In the bucket table, click the name of your bucket and then AWS logs. Then further down, the organizational structure, which is basically the date. There, we have our log file created. Let's go on to our CloudTrail console and observe our event history. Here, we can see our CloudTrail was created. We can go on and observe what is inside of this event. We have all the important information related to the creation of our CloudTrail, like the name of the trail, the bucket name, and the event source, etc. If we go back to our event history, we can view our other events here. Now let's go on and create an EC2 instance. Click on the search bar and type EC2. Click on Launch Instance. Here, select the first AMI. Next, leave the instance type to be default and click on Next. Leave the default settings as is and click on Next. We don't need to add any storage here because we are just creating a simple EC2 instance. So now click on Review and Launch. Click on Launch and for the key pair, from the drop-down menu, select Proceed without a key pair. And check the acknowledgements box. Now launch the instance and wait for some time. We have created our EC2 instance. Click on View Instance and wait for a while until the instance type is in the running stage. You can now see our instance state is running. Now go back to CloudTrail. We need to see our event history, if it has captured our event or not. It will take a few seconds to create a log file, so just wait for 5 minutes and keep refreshing your page. There, we can see our event as run instances. And that is how you can create your first trail and generate events, which is then viewed in the CloudTrail. Let's see a lab session on how does CloudTrail interacts with CloudWatch. In this lab session, we are going to look at what we want to achieve in regards to AWS Cloud Alerts with CloudTrail and CloudWatch. First, we have this S3 bucket which contains some files, and we want to know when someone uploads or downloads a file from it. So we're going to set up some alerting to achieve this. We're going to use CloudTrail and CloudWatch and SNS to do this, and it will allow us to immediately contact our security team should anything happen to our S3 bucket so that they can verify that access is allowed. We are going to enable the CloudTrail, which will give us the detailed log files about what is going into and out of the S3 bucket. These log files will be stored in the CloudTrail bucket, as well as they will be sent to the CloudWatch too. We'll use the metric filter to sort these log files and find the put and the get object requests. And then we'll use an alarm when on is found to send an email to the security team. We are going to do the following in our lab session: configuring a CloudTrail to log a CloudWatch log group, configuring a metric filter and alarm for testing and troubleshooting, configuring CloudWatch for S3 alarms and testing with CloudTrail. We are now in our AWS Management Console. We should create a bucket first, so go onto the search bar and search for S3 bucket. Give it a unique name. Here I'm naming it as Skill Curve Trail. Leave the default settings as is and click on Create. Our bucket has been successfully created, so go onto the bucket and upload some files here. Now let's check our CloudTrail and see whether our event was captured or not. Search CloudTrail from the search bar, click on the dashboard from the left corner, and observe the event history at the bottom. Right now we can't see our bucket creation event because it takes some time to log the files, so in the meanwhile we can create our trail. Give your trail a name. Here I'm naming it as Skill Curve Trail. Now we need to create a new S3 bucket so that the log files are stored in there. In this demonstration, I'm going to select the default bucket. Next, we need to uncheck the KMS encryption box since we don't want our logs to be encrypted, as well as our log file validation, so uncheck that too. Now scroll down and click Next. For our event type, we're going to select data events because we want to log the resource operation performed or within the AWS resource. Scroll down and the data event type will be S3 bucket. So select that and make sure that you are logging all of the events. Click Next. Now review all the selection we have made and then go ahead, click on Create a Trail. There you go. We have our file log up and running. Now let's go on to S3 we created earlier and perform some actions. Search S3 from the search bar. Here we can also see that our default CloudTrail bucket is created. Click on the bucket we made earlier and upload some files. Head on to CloudTrail and expand your event history. Here, you can see an event is generated on the creation of our bucket. If you want to open this, we can see the event record details here like the event type, the source, etc. Now let's log our CloudWatch log with our trail. Go to the trail we just created. Click on Edit and enable it. Here, a log group will be created with a name, so I'm keeping the default one. Along with this IAM role is also being created with all the needed roles. So let's just name that as CloudTrail role. Save the changes and you can see that our CloudWatch logs are made through the CloudTrail. Let's go on to CloudWatch to verify this log group. Click on log groups and there you can see the log group has been created. Click on the log group and select the recent log stream. Right now there is no log events because it takes time to capture the log files. Let's go on to S3 and upload some files there. Here you can see that we have added an HTML file. Now go on to the log events to check the update. Refresh it a couple of times and you will be able to see your timestamp along with message. Let's click any one of them to see what we have there. You can see what happened in your AWS account, like the event details, the event source, and the name. This is what you get as a notification when you set up the SNS topic. Now let's go back onto our log group and create a metric filter. This is to define what you actually want to create an alarm on. Select on the log group and click on Actions and create a metric. Under the filter pattern, enter the following. What this does is that first we want to event source to be s3.amazonaws.com. CloudTrail logs a lot of things from a lot of places. This way we're just saying make sure of the log is coming from S3. We have got to a presence. This means it must satisfy this condition and it must satisfy one of the two after it. These are the event name is either put object or get object. So that means someone has either put an object into S3 or they have obtained it or grabbed it from S3. Now click on Next and name your filter as metric filter and scroll down and name your metric namespace as metric filters. Now the name metric name as log metric and give it a value of 1 and leave the default settings as is and click on Next. Next, review and create your metric filter. There, we can see our metric filter has been created. Now to send an alarm on this metric, we need to create an alarm on this metric filter anytime it's triggered. So select the metric filter and click on create alarm. Here, we can specify our metric and conditions. Scroll down and keep the threshold to be static. When the log metric is greater than 1, that is when it's triggered. Click Next. The alarm state trigger is an alarm and we want to create a new topic, so let's name that as CloudWatch Alarm. We're going to select an email address that is going to receive this alarm. I'm just going to enter my email and now click on topic. Now this will send us an email for confirming the email address and I can show you that here I have got an email. So I will just click on the link and confirm the subscription. Now go back and click on Next. Name your alarm as Access S3 bucket. Now click on Next and review all of the CloudWatch logs and click on Create Alarm. There we have our alarm created. Now let's go on to S3 and perform some actions. So here I'm just gonna download 2 of the files and upload another one. We should receive an email about someone doing something in our S3 bucket. Wait for a few minutes until you receive your email. It typically takes 5 to 10 minutes to update. We have received our email. We can see that the Amazon CloudWatch Alarm Access S3 has entered the alarm state because the threshold was crossed and we have one API call which was picked up from the CloudTrail. This completes our lab. We have generated some of our event and it's going to load all of those API calls to CloudTrail, which will be caught by our metric filter and that will trigger our alarm, which will send a notification to SNS, which will send us an email.